combine different mixed reality modalities in an incremental way. So I wanna talk first about a little theory because it's an important part of the paper. Probably most of you know the basis, but it's an incremental work. So I'm sure you know this idea from the 90s that the physical world and the digital world are just opposite of a continuum. The important part of that is that they can be combined in different degrees. So if you think about your living room as a physical space and you think a video game as a virtual environment, you can play a video game in your living room for an augmented experience. Taking an example from UIST 2014, you can, Joan and colleagues propose Room Alive, where you scan your living room and have a cave-like experience in an arbitrary surface. What's interesting about this being a continuum is that we can move along. So we can combine the physical and digital in different degrees and then change that combination. One of the most archetypical examples of this is Magic Book, where it's a physical book that we can interact naturally, but then using see-through you can have an augmented experience, but you can also go inside of the place of the book for an immersive VR experience. So the thing about this continuum is that cannot reflect the subtleties of the different mixed reality projects. So there is something from '98 from Benford that contrasts the amount of digital information with the location of, where is the point of interest. So the combination of the two axes gives a really complex space, and the navigation is really interesting. So at the bottom left corner, you have the current space, right? And then at the top right corner, you have a full virtual experience. But then you can also move horizontally for a telepresence experience. Or also you can just stay where you are while increasing the amount of digital information. So this is a really nice lens to look at the literature on mixed reality systems. Looking back at Magic Book, we can see this diagonal going between the physical world into a virtual experience with a middle point in a sea presentation. So there are many projects that do this in different ways. In 2004, Benko proposed a collaborative mixed reality system to interact with archaeological information. So we are using mixed reality to go somewhere else. Then, sorry, this is this one. Then Kishokawa was working a lot in collaborative spaces where it's the same incremental amount of digital information, but at the base we have people working, the image is not really good, but the idea is you have people working face to face, so there is the physical world as the frame of reference, but they add more and more virtuality. Okay, so an interesting work for this paper is the MetaDesk from Ulmer and Ishii. What they do is they propose a way of exploring a map using different modalities, but the thing is the different modalities are coexisting at the same time. So you can use tangible interaction over a tabletop, but you can also use a see-through device. And the interesting thing is you can have one person swapping between modalities or different people having an asymmetric collaboration from a technological point of view. So what we propose in this paper is more or less in the same line of the literature, but it's trying to give a more dense coverture of this space as an ecosystem where you can build applications. And the idea is to do it from the ground up. So we start by users in the physical environment, okay? And then the first thing we do is we use augmentation to put the digital information directly onto the space, but that's quite limiting. So the moment you cannot increase the digitality anymore, you add support for see-through devices. So that gives us some liberty, but we are not totally free. So then if we need more control over what the user sees, then we add head-mounted displays. So in the paper, we explore this idea incrementally over two examples. And I think the best way of explaining you what I mean is to show you some videos. So the starting point is the physical world. So we can manipulate things, we can use physical tools, right? And also we have this pen and paper technology that we really love. And the thing is, by using augmentation, we can use similar interaction techniques, but creating dynamic content. And then again, this is just the fact that this is green light. The important part here is that we're adding that with light, so it can be dynamic content, and it's being digitalized in real time, right? The thing is, we cannot show media information, at least not without additional technology. So what we can do is we can use a see-through device. Imagine here is like a sphere floating on top of this 3D printed object, and we can use the see-through device to get that information while we can still manipulate the object, right? The thing is, the moment we move to see-through, then we gain the ray casting technology that we can use with any tablet. So then we can use pointing through this screen on the real scene. So we can use, the moment we increase the amount of immersion, we gain digital tools to use in the physical space. So if we want to override what the user sees, we can recreate the physical world digitally and then use a head-mounted display to navigate it. So here we can see, what you see in the left is not part of the system, but it's just a feedback of the user. So the user can manipulate the object, and in this case, is seeing a simulation of an engine running inside of the 3D printed object. We could also detach completely the physical and virtual representations of the same object. The moment we do that, also we break the tangible aspect, which is nice. But the thing is, we are gaining liberties, but also we are losing physicality. So in that path, what we can do is then use virtual navigation over this physical place we digitalize. Here you see the user jumping on the table to have a higher resolution of the space and be able to draw. It's not really visible in the video, but it's synchronized with the piece. The thing is, we cannot just jump near of where we are, but also we can move around to get a point of view that we could not naturally move. Let's say it's inaccessible, or I don't know. We can remove things we don't need, and also we can move around the physical space. So the idea of the paper is we present these incremental levels, and from my point of view, the conceptual side is more important than implementation, since the technology is far from being perfect. But the idea is we start in the physical world, we add digital information over the surfaces. When we need to have media information, we swap to, let's say, see-through, and then on and on we gain liberties. The important part is the moment we decouple we are free from the physical constraints, then we can move to a purely virtual environment. Instead of jumping on the table, I can go through the door into, I don't know, a video game or whatever. And what's important there is that it's framing the virtual world in reference with the physical one. So the whole system is supported using an overhead scaffold with a few projectors to have 360-degree projection and some OptiTrack cameras, and also the lighthouses from the HTC Vive. The point cloud you get is only a partial one, mostly because of interference. That's addressed in the paper. I think is one of the main limitations we have right now in this paper is going from this statically created scene into a scene that's created by scanning. But the problem is, the moment you want to have that technology, then you cannot use the tracking systems that are based in the same wavelength. So I think it would be ideal from where we are, move towards something more dynamically created, and to be able to use embedded systems as a way to increase the potential of the lower levels, let's say, of level 0. So I went quite fast over the paper because the important part is the conceptual framework, but we have been working on this topic since then, so I want to talk a little about that, and since I have time, I will do it. One of the things we did was working a use case with a colleague that's working for Airbus, trying to help them build virtual reality tools for collaboration. And they have this scenario where part of the, you have a set of experts with some qualifications working in a meeting room, right, and making decisions, and then you have a technician inside of virtual reality testing those design considerations. And the thing is, they have problems about the communication mostly. So what we created is using the same system I just described, let's say a hybrid collaboration scenario. This is a proof of concept, so it's not polished at all, but the idea is as if you're working in a cave, but in combination with a tangible interaction. So what you get is, here is like a world in miniature created with projection, and you can interact with that. And you have two users that have different degrees of information, right? Also, you can use a portal to go into the remote location and bring an object to discuss it. And you just put it on the table. Or you can move between locations virtually. Okay, here is you can discuss the thing you bring from the other place. And, okay, and then if you want to discuss or move information from one place to the other, you can just go through a door. And obviously, you cannot, we cannot display an avatar in midair, but we can add the virtual reality helmet when you want to do it. So the idea here is you can have different lenses that let you connect to the other place up to the point that you go into the other place. That's it, more or less on the same spirit of what I was describing. So finally, in the same, another thing that's not part of the paper, mostly because we wanted to have a dedicated paper on that, is the evaluation of these kind of systems. And not that much about can people use it is good enough, because applications are not there yet. It's more a proof of concept than anything else. The question is, can people complement the information? Does it make sense for them? So we built the study, is currently under evaluation. So the idea is each of the participants was interacting with an augmented mockup. It has a physical, augmented, and virtual versions. And the question is, how good are them to transport information from one location to the other? And the result we got so far is, I will go really quickly in a high-level way. Is that people interacting with the physical augmented and with the virtual reality helmet are as good to doing that or to put and remove the helmet each time. And what's crazy is that's even the case when they change in perspective. We cannot make them change the perspective physically, but if you see a physical element, when they see the physical scenario, they put the helmet and see the same scene from a different perspective, they have roughly the same accuracy when trying to estimate where the things were. And what's even more interesting for the VR community in particular is that the moment people were having part of the information in the physical space and part in the helmet, then distance compression was not a problem anymore. So this paper and the talk even, they are more high level than the other talks I saw so far, because it's not that much about the results I can show you, it's more about as a direction that kind of makes sense. And what's interesting now is that the technology is quite mature and we can build those systems. So the important part here is that the digital world is really powerful, but it's not always necessary. So what I propose to do, we propose to do, is to increase the amount of digitality progressively. And that way, we are framing interaction based on how the physical world works, even if we lose those constraints after. And based on those results we have that they still need the peer review and validation, humans seem to be quite good at doing that. So for me, what's interesting here is that in one hand, we're gaining liberties, but on the other hand, we are framing the virtual world in relationship with the physical one. So then the virtual place is somewhere. And that's one of the biggest problems we have right now is that this swapping between I'm here and I'm there without a transition. So I think that's actually not perfect for the brain. So that's it. Do you have any question?
Hi, Junya Lee from Kai, South Korea. I just had one question regarding the see-through display plane prop thing. Was that, you know, perspective corrected kind of fake transparency implementation, or just like iPhone, like AR kind of surface?
The thing we did was only like a fixed perspective, like a see-through, like a tablet augmented reality, but it will be completely possible to do perspective corrected, and it will be even better, I would say.
Okay.
We just did it for simplicity. We were not tracking the skeletons in most cases.
Right, thank you.
Hi, David Lindelbaut, U Berlin. Really cool talk, and I like that you went off the paper a bit. So you now can transition basically between kind of the physical and virtual with all these incremental states. Do you think that users constantly want to transition, or that they actually at some point will just kind of settle at one level of augmentation?
I think part of the idea is that we don't need all the augmentation. You should just use as much augmentation as you need. I don't know if that's the question.
But do you think that, so the user has like 6 different states he can choose from.
Yeah.
Do you think he will constantly change between those states, or kind of stay at like state 2 with kind of with the see-through display, or then stay another hour in the virtual reality or whatever?
That's a good question. Again, I think it really depends on the application. What I would say is that I think I found the same thing several times in the past, is that it's not that important that you give them the right tools, you just give them the opportunity to change tools if they need. I think that is a better approach, in my opinion.
So one more question, maybe following up on that. So in the implementation you showed, you had to put on a head-worn display or pick up something to go and use it. And so there were physical things you needed to do to move from one combination to another. So can you say a little bit about what you think might happen in a situation in which we have better technologies than we have right now? Okay, so I think, again, that's why I try not to go too much in the technical side, because it's based on the current limitations. And probably head-mounted displays will improve up to the point that someone was telling me yesterday that this is technology, and it's completely true. I mean, if I can have full immersive display with my glasses, then that would be perfect. But the question is more, I don't know. I mean, the problem I see with VR is that on itself, I think having to put a helmet to go somewhere else is actually an explicit action to say, okay, I'm not going to be here anymore. If the transition happened completely transparently, then I think it can have more problems. I mean, because here, progressively, you're going away from where you are. So I think it's important to be aware of that somehow. Okay, thank you. Anyone else?